Okay, so it's asking us to find the proportion between the circumference of the allowed Bohr's orbit and the de Broglie wavelength. Since we are talking about a Bohr's orbit and a small atom, we know all the equations we can use must be quantum equations. There is no other equations that allow us to predict and quantify the behavior of this small atom at the length of a Bohr's orbit besides quantum equation. So we sort of have this model here. We have this central nucleus, sort of these edges or these orbitals. So these energy levels, and these orbits are what we call the Bohr's orbit. So it's asking us what is the ratio between 2 pi r and lambda, right? And in this case, 2 pi r over lambda, that's our unknown. The only things we know to find is r and lambda. And r in this very, very small scale will be a small number, right? It'll be sort of course, this is a large in the scale of an atom. 1 radii will be extremely small. Besides that, we need to find lambda. What does lambda have to do with anything? Okay, so at this very, very small scale, electrons and atoms and these very small particles, these point charges, or point particles really, they behave like waves as well. This you can see from the double slit and single slit experiments, the photoelectric effect. A bunch of these experiments prove that when observed, these particles act like waves. When not observed, they act like individual discrete. So since they act like waves, we can actually get a wavelength for these particles, or a lambda. And again, since we're talking about Bohr and de Broglie, they're sort of hinting at what equation we should use, right? And the Bohr's model, when it comes down to it, the Bohr's model is the model that you're sort of familiar with from high school, in that you have a central nucleus and a bunch of orbitals, right? And there's a way to calculate how many electrons can fit in these orbitals and how far away these orbitals are. Nonetheless, this is a Bohr model, right? That's the Bohr model. And then de Broglie, he had his own hypothesis, and it was just this, that they act like waves. And then he quantified this with an equation, right? So what being asked here is, what is the ratio between the path this electron takes, right? Because the path it'll take will be the circumference of this orbital, which will be 2 pi r, over the wavelength of this individual particle. We know the following. We know that n, let's